I'm going to talk about a true story that happened in our project recently. And yeah, it was a day everything actually went off. And I'm talking about the challenges and the problems that we got and how we solved them, and all the problems actually kind of occurred after that problem. So let's see. So first, because yeah, you kind of have to know a little bit about our architecture diagram and our deployment workflow. Then I'm talking about the first sign of the problem, then the deep investigation that we made, and also the breakthrough that we had after the investigation. And then, as I said, like kind of other problems happened, and we had to investigate on unexpected data processing delays that we had, and then later on the data anomalies that we saw, and then the conclusion and the lessons that we learned. So here is our architecture diagram. As we mentioned, we are using Snowplow, which is like a data pipeline tracking solution. And we have, actually, Snowplow provides us with different modules. And the way it works, I'm not going to go through all of this diagram because it's too much detail, but the whole kind of picture is that we are tracking the mobile app data, and the tracker actually sends the events to our main first module, which is the collector. And then we have, after collector processes the data, it sends it to enrichment module. Here we, for example, dropping the IP addresses because we are not doing any personalization on the data. And then enrichment passes the events to the loader. Then here it comes to shredder. We actually kind of cut the events into smaller chunks. Then it comes to our Redshift. And here we have also data modeling. We are using dbt for our data modeling. And then we also pass the data to another Redshift. And then we have our Tableau servers. Then our workflow is also, we have 3 environments. We have dev, staging, and live. Dev is for our developer sandbox. We are doing testing and development. And then staging is usually the platform we are using when we are having a new clients. We are using that environment for them. And then the live is actually our production environment, which actually the real data stands there. So what happened, actually, it was 25th of October. We usually, we have set up some kind of notifications for our dbt run, because this is very important for us, so that because actually the data which we get every day, this actually updates our dashboards, and we have clients who look into the dashboards every day. So on 25th of October, I noticed that we didn't get the success run report of dbt in the email from the last night. And I was like, okay, usually a lot of things happen with dbt during our project. So I was like, okay, another dbt thing. I was like, okay, let's trigger the ECS task. I hope everyone is a little bit familiar with the cloud, AWS and stuff, because yeah, the time is limited. I cannot go through everything related to cloud, so I just mentioning it. Sorry for if you're not understanding something. So I triggered the ECS task for the dbt to trigger it manually. But usually this would solve the problem, but then I got this error, that resource initialization error. So it was saying that I'm not able, the task cannot pull registry auth from Amazon ECR. So there is a connection issue between the task and Amazon ECR. So ECR and ECS are 2 different services at AWS. ECR is the place that we actually have the Docker images, and ECS task is the person who kind of needs to run those tasks, had to kind of get those images from the ECR. So these 2 people couldn't talk to each other. So I was like, okay, let's investigate what happened from yesterday. Usually, this stuff when happens, you have to look into what you have merged into your live environment. So first thing I was like, okay, who touched the pipeline yesterday? And so a colleague of mine, she merged 5 updates for a pull request, like library updates, like normal library updates, and to the live the day before. And all of them were successful. I was like, okay, probably something was going wrong in those libraries, and like it caused some problems into the data pipeline. So the first thing, reverting all those pull requests. Reverting all those pull requests, as I said, we have 3 workflows. And when you create the reverts, it actually make another pull request, right? It has to go through all of those stages. And then when it was going through the dev, everything was fine. And then it was going successfully, deployed successfully to dev. And on staging, it was taking time, 30 minutes. 45 minutes, something like that, and then giving a timeout error, like the worst error in software engineering. There is nothing, just timeout. I was like, okay, what should I do next? And then I was like, okay, I do not revert. I create a new PR and add those changes myself, like kind of revert them myself. Again, timeout error on staging. Then I was like, okay, if dev and staging is like dev was fine, staging is going to come. I would silence those 2 workflows. I would push directly to live. We usually do not do that, right? I was like, okay, whatever, we are going to do that. I don't know, I have to revert those. Probably something was wrong there. And then that one also didn't work. So that was my mind, actually, error, like this. So I like, okay, something looking back to the error again, here it was like a bit of, I would say, kind of bad synchronicity, because that topic, like the merged pull request, completely dragged my mind to that like something was wrong with those pull requests. So I came back to the error. I was saying, again, the connection issue. So I was like, okay, then really something fundamentally means it is broken in the network. And if you're familiar a bit with the networking on the cloud, you know that there are a lot of things on the network that you can configure, and a lot of things can go wrong. So here it's been like 4 days that we don't have data, and like add kind of also a great amount of stress to that in that stage. So I had to look into all of these kind of modules, like security groups, IAM roles, VPC, policies, network ACLs, elastic interface, network interface, subnets, route tables, NAT gateways. And all of them had to be kind of compared to the dev, because every 2 minutes I was like, why then everything works on dev? Because we have one kind of source Terraform code that we deploy to all 3 stages. So why things are working on dev and doesn't work on staging and live? We have everything the same. Nobody has changed anything. And then, yeah, looking into all of them, we couldn't figure out what is wrong. Everything looked perfect. So then what we did, we tried to replicate the whole infrastructure on another AWS account. So to see that if we can recreate the error. We were successful, and we recreated the error, and we saw that there is, in the staging and live, some of the network ACL rules were missing, actually. What is network ACL rules? If I have to explain it very kind of in a simple word, is that, like, imagine we have DHL in a digital format, like in future definitely we will have. DHL comes to this building, and it has like a number, like a, I don't know, something has written on the package that like you have to go to number 6, for example. And then the poor thing is coming, but somebody from the source has changed the number that the packet should go, but didn't inform the digital ones where to go. So this one was like confused where I should go. Actually, network ACL rules are like these kind of rules that we define for the inbound and outbound rules that like how the traffic should come to our VPC, to our virtual private cloud. Yeah, as I said, we didn't even have the permission to add or delete those rules. So again, but the thing is, we have our kind of very first network, cloud network configuration is done by a team called Basic Platform. And these people are actually they were located in India, and it was also Diwali at that time at India. So it was a hassle also to find those people to add those rules that were deleted. So what they did, they kind of introduced some network rules that those rules overwritten our custom rules. And they said we didn't thought that this would like kind of affect your rules, like the custom ones that you had. And so yeah, this whole miscommunication was also there. So we were not aware that like such a thing has happened. So what happens when you change those rules is actually traffic, all the network traffic will be completely blocked to your VPC. It means that like nothing will come to your VPCs. And since like we are like the whole infrastructure is also on the cloud, and we are using a lot of AWS services, and they are interconnected. Like as I said, ECS needs to take the images from the ECR, and then if ECS doesn't work, then this doesn't go to the next level. Like the whole domino effect of kind of bad events, kind of like this. And it was a nightmare to figure out what rules are missing. And like, if you're also familiar a bit with the NACL rules, that like if they change it in a way, first of all, they are stateless, and if they change it, for example, if rule number 1 actually matches, the other ones which are on the list, they would completely ignore it. So if you also have it like in a rule that kind of let the traffic in, but if the first one actually take precedence, then the rest doesn't count. They don't count the rest. So that was also very hard to figure out what is exactly going on with those rules. Then, yeah, we changed the NACL rules, and we thought that, okay, everything should go back to normal, right? 1st of November, we were successfully able to write back all those rules to our inbound rules. Then we try to monitor what's going on. As you can see, these are the user activity dashboard data. And when I said like this is the 24th of October, from that night on till 1st of November, we completely lost the data. And at least in our what you see now, I would tell you later. And then from 1st of November, as you can see, we are supposed to get like around 27,000 something like data in this dashboard. And we were receiving like 4,000, 2,000, something like that. And then 1st of November, 2nd and 3rd, and on the 4th, the number has jumped to 3368, something like that. This was absolutely not normal. And so we were trying, and then we were also looking into our Redshift. We were receiving data with a lot of lag. And because we are supposed to get the data in a near real-time kind of manner, but we were receiving it with huge delays. Then also, as you saw in the collector module, when the tracker sends the data to the first module, which is collector, after that we have like in the collector we have a SQS buffer. So it is like a mechanism to not put everything at the same time to the other module. So it put all the events in queues and then put it like in a bad stream and good stream. If it doesn't match with some criteria, go to the bad. If it's okay, go to the good stream. And then you can see also there is 33,000 messages were also got stuck in the queue. So we were thinking that, okay, different data were coming to our mind. Things are stuck in the queue, data coming with the lag. Why we had the pipeline running on 1st of November, why it was not working as expected, why things are coming with the delay, and all these kind of questions were in our mind. So we had different hypotheses how to solve it, basically. So we said, okay, collector container, probably because we were off for 7 days, probably doesn't have the capacity to process these incoming events, and it is not able to move these 33K messages which are in the queue. So we said that, okay, we actually do some vertical scaling, which means that we add a memory, CPU and memory to our ECS cluster. So it gives more power to the ECS to kind of process those information. But it didn't work. We were still getting the data with delay and not in an amount that we were expecting. And then again, moving this, we said, okay, let's move the things from the queue. Maybe they are blocking. So let's move the queue. And you can move manually these events which are stuck in the queue to that other queue. And also, after collector, there was another module called enrichment. We thought that maybe also enrichment is not able to handle this amount of data. Let's also increase the number of the shards for the enrichment as well, giving everyone the power to work, but it didn't work. Still getting data with a very bad kind of manner and behavior, so to say. And then, as you can see here, we also, in this enrichment container, we have actually, which sends the data to SP enrichment good stream and bad stream. And here we also have two S3 buckets, which one S3 buckets for the bad streams, which we keep those bad stream events to kind of for further analysis to see what was going wrong and stuff. So I was like, let's look into those files from the S3 bucket bad enrichment and see what's going there. So we were seeing most of the events were getting access denied or server unexpected server errors. I was like, who denied the access? Yeah, before it was like that, but now we are not like blocked by this thingy. Pipeline is working. So what's going on? Again, trying to analyze this access denied, unexpected server errors, we didn't get also that much specific finding out of it. And till I said, okay, let's go to the data actually to see that like, what's going there? Because here, one of my colleagues said that like, yeah, we have all the events are going to the bad enrichment bucket. I was like, okay, not. In the normal scenario, when we are also getting the data, it is very common that, like, I mean, it is actually how it works. Some of the events go to the bad enrichment because of several reasons, not compatible with the schemas, and most of the time is a schema violation. So when we get like lots of events, some of them also always goes to the bad enrichment bucket, some of them goes to the good stream. So it's normal that we see bad kind of events in this bucket. And then when looking into the data, this figure shows the number of the good events which is on the Redshift. So this table comes directly from Redshift. The blue line is the good events. And on the 4th of November, we got 32 million good events, and 23K orange line was the bad events. So if you compare like the ratio, it is normal. So not all the events are going to the bad bucket. But the problem was why we got so many data on 4th of November, like this 32 million spike. If I want to say you, the normal amount of data that we should get every day is around 5 to 6 millions. And then, as you saw also in our architecture, there's collector, there's tracker, like your mobile tracker. Then you send the data directly to collector. And there was like nothing in between that we store the data. So does anyone know that, like, what could be the reason that we got 32 million events on 4th of November? Any idea? Not from my colleagues, but.
The network retries, like the network didn't succeed and tried it again progressively later and later.
Yeah, but why it didn't send it, for example, on 1st of November as the pipeline was working and stuff? Any other ideas? You can tell it to me, not your friend. Yeah, no idea? Yeah, we didn't know either. Yeah. So we started to kind of investigate, because when we were talking with my PO, like he was saying, you know, the data got stuck somewhere. I was like, there is no somewhere. We don't have anything in our pipeline to store the data. I cannot really accept this. So there is no somewhere that these 32 million events were kind of stored, and then they got released or something like that. At least not in our pipeline. I was 100% sure. And then I was like, okay, only if and the data root timestamp, so the timestamp of the data was 4th of November. It was not related to the outage dates, like the dates that the data were, that we didn't have the pipeline. So I was like, if you say so, if they were like stuck somewhere, it means that also somebody has actually manually overwritten the date of the events, because this cannot work. And then I tried to figure out like where can this somewhere be, because at some point it also could make sense, right? It was released somehow. But then there is also, as I said, we have this bad enrichment S3 bucket that we previously take a look into that, and we couldn't figure out what could be wrong, which with these access denied errors and stuff. Then I was looking specifically to the timestamp column, timestamp, like search for the timestamp, and I saw that we have 5 different timestamps there. What we usually, like, it's been 2 years I'm in this project, the whole time I was hearing root timestamp, root timestamp. And for me, root timestamp was like the collector timestamp, because the time that the events hit the collector, and we also process that, right? As I said, it's a near real time. I was like, okay, maybe root timestamp is another one, because I saw that device created timestamp, device send timestamp. So it means that there are differences between these kind of things. So the time that the device sent the data can be different than it was created. For example, you have your phone, you press something, and suddenly, I don't know, you lose network or something like that. So that timestamp that you created is different when it is sent to the collector. So this, in this file, we saw different timestamps, and I was like, okay, this means that, as I said, there was nothing on the track on our pipeline that the events were stored. I was like, okay, these timestamp is coming from the tracker, so probably there is something in the tracker side. And I started to investigate on tracker, because usually we are data engineers and we do not configure the tracker configuration. And our iOS and Android developers, those are the people who configure those kind of information on the tracker side. And so what tracker actually does, the tracker sends the events asynchronously in batches. using post requests. And it sends in batches to collector. And after the collector, in this SQS buffer, after that queue, it goes to the good stream. And then after the collector, it reaches to the enrichments. And enrichments in the enrichment module, it becomes like single events. So before that, the events comes in batches, like 500 events, 500, for example, clicks in one kind of considered as one event for the collector. And then the events are stored in an internal component event store, which is a SQLite database. So things are now making sense. So the whole time which our pipeline was not working, the tracker was trying to send data to the collector, but it was like getting into a dead end. So it was like, and then the events were kind of stored in the SQL database. And then tracker also has this exponential backup period, which is for the retry attempt. So this is actually a very good mechanism to not to throttle like an endpoint or something. But in this case, kind of for us, worked in a way that like all these failed requests, for example, if I try now at, I don't know, minute 5, if it fails, the second retry will also increase in an exponential way. So the time was increased and increased and increased and increased for the next retry, So it was 7 days out of service, the whole pipeline. So this time was actually were added and added. And yeah, as I said, this actually is a very good mechanism from Snowplow to actually not to lose data when something is actually goes wrong with our setup. Like in the documentation, they also say that, yeah, it's very rare that you lose the connection with your with the collector, but in case, yeah, that was one of the cases, so that they kind of stored all our events in this SQLite database. Yeah, as I said, yeah, to conclude that it was, so the whole thing was out of service for 7 days. And these events were kind of queued in this buffer from the tracker side. And also, although the connection, yeah, as I said, this retries actually has this exponential effect, so it kind of get added and paused and loaded and slow down actually also, even though the connection were restored. Because we also found some mismatches in the load balancer logs, which showed like still we have unusual behavior between the ECS task and also the ALB, like load balancer, which we actually is another module from AWS, which kind of distribute the traffic. So also, again, there were like some, because load balancer also needs to send this traffic to the targets, and ECS was one of the targets, and it was giving, in the logs, we were seeing a lot of unhealthy checks. So still, there were some not a stable connection for us after 1st of November. And then suddenly after, I think on 4th of November, kind of it got like its trust back to the pipeline, and all these events got released all of a sudden. And it was a very kind of painful and also at the same time very interesting experience for us. And we think communication is really the key. If in the first place we know from our colleagues that these kind of things have been changed, definitely we would have known or expected something like that, and we were not like confused or going into bad, like wrong directions, what could have been wrong. And I also thought that we could have maybe created some custom metrics and enabling some alert for unusual patterns, because we never faced with these kind of issues. We never had also, for example, we could have some custom metrics for high error rates in the batch stream, spikes in the queue of the backlog, or tracker buffer side. So these are also the configuration that like our developers could work on. And also some metrics if the data lag is exceeding X amount of time or something like that. And one thing that was also very helpful for us was like going back to the data and showing and seeing the trends. Actually, that was the most helpful things to see that like how the data behaves and how it was kind of leading us to understand where to go. That was actually, I think, the best thing to know. And also like, yeah, auditing this tracker configuration with our iOS, Android developers, because we were, as I said, we were never in touch, so we didn't know what they are doing and what is this tracker configuration, what is it doing? Do we need to increase the batch size, decrease it, or do we need to have any, for example, purge policies? Because with these 4 million events, 42 million events, we also received data from, for example, a year ago, which were failed. And the thing is with that buffer, if the events are failed, they will kept in the SQL database. And if you do not implement some strategies to delete them, they will stay there. So they would also make problems for the database, SQLite database there. Yeah, and that's it. Thank you very much for listening. And if you have any questions, I hope I